1 kg of an ideal gas whose gas constant is 400 joule per kilogram Kelvin. Specific heat at constant volume is 1000 joule per kg Kelvin at 1 bar and 300 Kelvin is contained in a sealed rigid container. During an adiabatic process, 100 kilojoule of work is done on the system by a stirrer. The increase in entropy of the system is, so we need to find the entropy change or the increase in entropy of the system in joule per Kelvin. From the first law of thermodynamics, the change in internal energy of the system is equal to the heat added to the system minus the work done by the system. Now for this problem, it's given that the process is adiabatic. Okay, so adiabatic process. That means the heat added in the system will be 0. There is no heat interaction in the system. Therefore, this term goes to 0. Again, it's given that 100 kilojoule of work is done on the system by the stirrer. That means work is negative. So, the change in internal energy delta U will be equal to W for this problem. And W in the problem given is 100 kilojoule. Now we know that for ideal gas, so let's write here for ideal gas, change in internal energy delta U is given by mCV into delta T. Delta T is the change in temperature of the process. Now let's say the adiabatic process takes place from state 1 to state 2. So we can write delta U in problem, it's already we have found is 100 kilojoule will be equal to mCV into delta T. So it will be T2 minus T1. Okay. So from here we can find T2 is equal to 100 divided by mCV plus T1. So this will be 100 divided by m, that is 1, and Cv is also 1, plus T1, the initial temperature is given 300 Kelvin. Therefore, we got the value of T2 is equal to 400 Kelvin. For an ideal gas, the change in entropy, so let's write here change in entropy for an ideal gas this can be written as delta S, that is change in entropy, is equal to, in this case it is S2 minus S1, okay, because from 1 to 2 is an adiabatic process, will be equal to mCV ln T2 by T1 plus R ln V2 by V1. Now we know that in the problem is given V2 is equal to V1 because volume is not changing. So ln V2 by V1 will be equal to ln 1, which is equal to 0. So this term will be 0. Therefore, S2 minus S1 will be equal to m, that is 1, and Cv is 1000, ln T2 is 400, we just found the value here, by T1, that is given 300. So delta S will be equal to 287.68 joule per Kelvin. Now let's go back to the problem. The increase in entropy of the system is 287.68 joule per Kelvin. For detailed information on entropy change, you can refer to the NPTEL course lecture number 43, Entropy Change in Closed System Examples, on Concepts of Thermodynamics by Professor Suman Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.